I'll give you a little introduction to inverse functions, and then we'll leave it at that. Before we actually talk about inverse functions, we have to talk about something called one-to-one. Here's what one-to-one means. A function is one-to-one if every input has a unique output. What's unique mean? Only one. Only one of that happens. You guys are unique. Oh, you're special, right? Do you exist anywhere else in the world?
Yes.
You do? You're awesome. Okay, there's no one else like me. There's no one else like me. All right. There's no one else like you. You are unique. Right? No one is exactly the same genome as you. No one has the same exact set of traits that you have. You with me on that?
Sure.
One-to-one means every input has a unique output that never happens again. It's just one of them. So one-to-one, a function is one-to-one if each input has a unique output. Let me give you a quick example. We'll talk about something called the horizontal line test and be done for our day. So we're going to pretend there's a function that has only 4 points. This is it. This is the entire function here. 4 points. And here's another function we'll compare it to, okay? What I want you to do, these are points here. What's your x coordinate for this point? What's your y coordinate, everybody?
3, 1, 0, -2.
X's are known as inputs, yes? Y's are known as outputs. What are your inputs here? -1. What are your outputs here?
3, 1, 0, -2.
Here's what one-to-one says. It says you look at your outputs. For each different input, you must have a different output. So every output has to be unique, has to not happen again. Do any outputs happen twice?
No.
This is one-to-one. Read me your inputs here, ladies and gentlemen, please. Read me your inputs, please.
7.
No, inputs.
3, 6, 2, -6.
What are your outputs, please?
2, 3, 14, 2.
Do any of your outputs happen twice?
Yes, 2.
If your inputs happen twice with a different output, it's not a function. If your outputs happen twice, it's not one-to-one. Do you understand the idea of one-to-one?
Yes.
Outputs are unique. They don't happen twice. Now, one thing that we can do... Oh, we have a minute. That's awesome. One thing that we can do... We can talk about this according to the horizontal line test. Now, you've already had something called the vertical line test. The vertical line test tells you whether something's a function or not. The horizontal line test will tell you whether something's one-to-one or not. So first thing, let me refresh your memory on vertical line test. Vertical line test says, imagine a vertical line. If it hits the graph at more than one spot, it's not a function. Note that all of these are functions. Everyone passes the vertical line test. Do you agree with that? Okay. Horizontal line test says, instead of vertical, this means horizontal, check it. If the horizontal line, any horizontal line, touches the graph at more than one spot, it's not one-to-one. And here's the reason. Because if I have horizontal line, check it out. Horizontal line touches this at how many spots?
2.
That means you have the same output twice. Do you see it?
Yep.
Same output twice. That means this is not one-to-one. So the horizontal line test will tell you that. This is not one-to-one. Is this one one-to-one?
No.
What do you think?
Yes.
Horizontal. Does any of those touch it twice?
No.
That's one-to-one. How about this one? One-to-one or not, folks? What do you think? One-to-one. How about this one?
No.
Definitely not. It's all, I mean, it's all the same point, right? This is not one-to-one. This is all the same output over and over and over and over and over and over again. So not one-to-one. How about this one? Look carefully. Well, there. How about that one? Is that one-to-one or not? What do you think?
Yes.
Absolutely. It doesn't cross over anywhere, right? That means that every output only happens one time. They're unique outputs. So one-to-one. How about this one? Is this one one-to-one or not?
No.
Definitely not. In fact, you get 3 spots here, not one-to-one. How many people understand the idea of one-to-one? Good, that's fantastic. Well, good morning. Okay, so we have these things called inverses. Now, I haven't even told you what an inverse is yet. So let's talk a little bit about what an inverse is. An inverse are these functions that, quote-unquote, undo each other. So here's what that means. It means if I plug something into a function, then the inverse should take what I plugged in and give me back take what I got out and give me back what I plugged in. So it's like, if I plug in a number 3, goes through this function, the inverse will take that output and give me back 3. So it will basically undo everything that you did. It's kind of like this. Like if you were cleaning the house and this guy came behind you and just messed up everything. That would be he would be your inverse. So like you'd go clean the kitchen and he would come along and put everything back the way it was before you cleaned it. Does that make sense? So it's like undoing everything a function did. That's how an inverse works. It takes an operation and undoes it. So it puts everything back to where it was originally. That's this idea of an inverse. It undoes a couple things. Now we've actually talked about inverses your whole math career. An inverse of addition. What's the inverse of addition? Yeah, undoes it. What's the inverse of division? Sure, what's the inverse of squaring a number? A square root. Yeah, that's the inverse idea. Now, what we learned last time was also something called one-to-one. One-to-one meant that if a function has an output, every one of those outputs is unique. So we have all these different outputs going around. If a function is one-to-one, it means that none of those outputs is ever repeated. So we talked about that last time with the horizontal line test, and that's where we're left off right now. Now the cool statement is this. A function has an inverse if and only if it's one-to-one. That's called a biconditional statement. Biconditional means it goes both ways. So a function has an inverse if it's one-to-one, and automatically, if it's one-to-one, it must have an inverse. Do you see how that works? It goes either way. So if a function does have an inverse, it is one-to-one. And if it is one-to-one, it must also have an inverse. The way we write an inverse for some function like f, so for a function f, the inverse is denoted, we use the same letter, f. We use the same letter, however, if we don't want to call this thing an inverse, here's how you write it. Watch carefully on the board. So for a function f, the inverse is denoted still f, but you got to show it's an inverse, and here's how you do it. Now, please listen carefully. I don't want you to get confused on this. To write an inverse, you say this. There, you put that -1 right there. That's a -1. You don't say f to the -1. Okay, here's the thing. That is not an exponent. It doesn't mean 1 over f. That is not what it means. It's simply the only way that we have to put an inverse of a function. Are you with me on that? So is this an exponent?
No.
No. It's pronounced f inverse. So let's all say this with me. For a function f, the inverse is denoted, what is that? F inverse. Don't say f -1. Okay, don't say that. That -1, we're not even calling it -1. It's called an inverse. So that is f inverse. Raise your hand if you're okay with that. And also one thing you need to know is that this thing is also one-to-one. So a function and its inverse will both be one-to-one. That has to make sense because they are inverse operations. They're inverse functions. They have to undo each other. So if this function has an inverse, it's this. But then this is also the inverse of that function. So those two things work together. Now, we're going to do a very simple example to illustrate an inverse. Are you guys ready for it? All right, so let's pretend that our function again, function f, has only 4 points. Okay, watch carefully. I'm going to explain to you how an inverse works. First thing, can you tell me my inputs, please? What's my input here?
2,
And?
-1, 0, 7.
Outputs?
-4, 13, 0, 8.
Good. Here's what an inverse must do. It must give you back what you started with. Now pay attention. Here's the whole operation of an inverse. What this function does is this takes this number, does something to it, and gives you out that number. Are you with me on that? So you plug in 2, but you get out -4. You follow? You plug in -1, you get out 13. You plug in 0, you get out 0. You plug in 7, you get out 8. An inverse has to undo that. So tell me, if I originally plugged in 2 and it gave me out -4, think outside the box here. Can you tell me what our inverse has to plug in and what it will give me out? I'll give you a hint here. I'll give you a hint. If I plug in 2, that's what our inverse has to give me out. Does that make sense? It's got to undo everything. So what number has to go here? A 2 has to go there. What number has to go here?
-4.
-4. Here's what an inverse does. Watch. Check it out. If you're not following that, here's the whole thing. Some of these people were kind of thinking outside the box and get this idea already, but watch if you don't. My original function took the point 2 and gave me out -4, correct? My inverse has to undo that. So it says, well, if you're plugging in 2 and you're giving me out -4, I'm going to take your -4 and give you right back the 2. Does that make sense to you? That's what it's doing. It's undoing it. Let's try this next one. This function says, okay, you're plugging in -1, I'm going to give you out 13. My inverse has to undo that operation, so it's taking my 13 and giving me out how much? Are you following it yet? Okay, good.
Oh.
Oops. How about the next one? Can you figure out what the next one's going to be? My original function takes 0 and gives me out 0. What's the inverse going to do?
0, 0.
Yeah, that one doesn't change at all, right? And last one, my original function gave me 7. I'm sorry, you plugged in 7 and gave me 8. What's the inverse going to do there? Can you guys figure that one out?
It says 8, 7.
Yeah, it says, well, I'm going to take the 8 that you gave me out, I'm going to give you back the 7. It's undoing that whole operation. So basically, what your inverse does is it gives you back what you started with. How many people understood this idea? So how would you say in English for someone who really didn't understand the inverse, what are you doing from here to here? What are you doing?
Going backwards.
You're going backwards, sure, you're finding the inverse, but what are you actually doing point by point?
Switching one.
You're switching. Switching what?
Input and output.
What are the inputs and outputs as far as the coordinates?
Y.
You're switching x and y. That's what you're doing. That's what an inverse does. It switches x and y. It says, well, think about it, guys. Think about it. If you're trying to get out what you plugged in, all you got to do is switch your x and y. Right? That's switching inputs and outputs. So, to find an inverse, we just switch x and y. This undoes what was done. And this undoes what was done. It's as simple as that. Now the problem is, The problem is, we normally don't see functions like this, do we? We normally don't see that. We don't see, oh, here's your 4 points, you know, do something with that function. We don't see that. How we normally see functions is something like this. We see f of x equals some sort of an equation here. That's typically how we see functions. Is there a way we can find the inverse for this thing? Well, I'm going to say to you that it's going to be really, really similar to this idea. In this idea, were you with me that all you got to do is switch your x and y? Because it's taking what you got out and making it what you're plugging in, right? That's what it's doing. It's going to give you back your original. We can do the same thing here. Here's your steps. There's only, let's see, there's 4 steps, but they're very, very easy steps. Number one. The act of finding an inverse really comes down to, can you switch x and y? The problem is, do I have a y up here right now? I don't see a y. However, some of you are saying, yeah, because you probably understand that one of these things stands for y. What up here stands for y? So instead of f of x or g of x or whatever your function is, write that as y. That's your very first step. So write as y equals instead of f of x equals or g of x equals. Write as y equals. So up here on the board, instead of f of x equals x minus 6, what am I going to have, ladies and gentlemen, please? Yeah, that's all I'm doing. I'm switching my f of x with my y. You okay with that so far? Okay. Now the next step. Next step says, now you're going to go through the action of finding an inverse. Watch carefully what I'm going to do up here, all right? To go between this problem, this function, and my inverse, I had to switch my x and my y. You with me on that? I had to switch my x. I did that for every single point. How can we do that for every single point in general in a function? Well, you're going to do exactly the same thing. If finding an inverse means I'm switching my x and my y, what do I have to do here? That's going to do that for every potential point that I ever get. Are you with me on that? It's going to switch my x and y forever. So what I'm going to do is, you're not moving anything around. Where you see a y, what are you now going to put? And where you see an x, what are you now going to put? That's switching your x and your y. You're making your y's x's and your x's y's. Nudge if you're okay on that one. That's how you find an inverse. That's what we did here. That's what we're going to do up here as well. So step number 2, you're going to switch x and y. Can somebody out there read me what I should have down on my paper, please? Say that louder. Good. Instead of y, I now have x. That's all I'm doing right here. I'm switching x with y. Instead of x, I have y. Very good. But the minus 6, that stays there. I'm not changing anything at all except for a couple things here. One, f of x becomes y. That's how we have to get started because we're going to switch our x and our y. We had to have a y somewhere. Then we switch these two things. We say, oh, y's now become x's. X's now become y's. So instead of x's, you write y's. Instead of y's, you write x's. Not sure if you're okay with that. Okay. Well, what now? We're almost done. We're almost done. We have two little steps left. The first one takes a little bit more work than the second one. The third one takes more work than the fourth one. Can you solve that for y? Yeah, that's what you're going to do now. So solve that thing for y. It shouldn't be very hard. You shouldn't have a whole lot of steps there. So step number 3, you're going to solve for y. Solve for y. How do you solve this problem for y, ladies and gentlemen? So I'm going to get x plus 6 equals y. Okay, on a show of hands, how many people are with me on this so far? Good, I have a few people not, yes, no? Yeah, okay. So what we're doing, we're writing our f of x as a y, no problem. The whole idea behind an inverse is you're going to switch x and y, because what you're plugging in now becomes what you're getting out. That's the whole idea. So our x's become y's, our y's become x's, then we're going to solve for y. And the last step's an easy step. Because you're done. You actually have your inverse on the board right now. Here's the idea. You're going to write your y back as your function's name. So my function was the function f, yeah? I want to write this as an inverse function of f. So this is f inverse. I just have to write that. So I'm going to replace my y with f inverse, with that inverse. So instead of y, I now have f inverse of x. You gotta have the x there, so tell me what your variable is. Equals x plus 6. That's my inverse function. Raise your hand if you feel okay with how to get that thing. Now, do you want to see why it works? You want to see why it works, that it would do this every single time, that it's going to do this for you? Check it out. Give me a number between 1 and 5. 3. Okay, I like 3. I want you to do this for me. Plug in 3 here. What do you get out of if you plug in 3? You get -3. You with me? Take the -3. I hope you're all with me on this. Take the -3, plug it into here. What's -3 plus 6? Isn't that what you plugged in originally? Do that with any number. You take 10 if you want. What's 10 minus 6?
4.
If I plug in 4, it should give me out 10. It has to do that. That's the inverse. Plug in 4, what's it give you out? Do you see how it's undoing the whole operation of this function? It's undoing everything you started with. It's getting back to what you started with. That's the idea of finding an inverse. It's not hard to do. It's not hard to do. You replace it with y. You switch your variables. That's the key step. You solve for your y, and then you replace that with your f inverse. Let's do a couple more examples. I'll give you one to do on your own. Talk about 2 more of them, and we'll show you graphically what these inverses are doing too. There you go. Find the inverse for me. If you're feeling like a rock star and you do that one really quick, why don't you try the next one? It's not any harder, but we're going to do this one together in just a bit. So let's see here. So first example, well, we know that finding an inverse means somehow we're going to be switching our x with our y, right? So we're going to have a y up there. So the first thing you do, hopefully the first thing you did, is replace your f of x, whatever your function is, with a y. Did you all do that? Good. So up here we're going to go, okay, well, now we're going to have y equals 7 minus x. Just a little change there. Instead of f of x, you put y. Yes, no? Next thing is the most important thing. Now you're switching your variables. This is the act of finding an inverse. That's what we did up here with our simple points. That's what we're going to do here as well. So if you switch those variables, instead of y equals 7 minus x, you're going to have x equals 7 minus y. Raise your hand if you made it that far. That's an important step there. Good. Okay, that's great. Can you solve that for y? Can you solve that for y? Because that's your next step. You need to solve this thing, get y by itself. How do you do that? You can subtract 7 if you want. Sure, you're going to get x minus 7 equals negative y. If you do that though, check it out. You're going to get x minus 7 equals negative y. Yes? You're going to leave it negative y? No, you're going to change the sign by dividing by negative 1. that means you're going to have negative x plus 7 equals y. Or you could do this a different way. Over here, you could have added y and subtracted x, you know? You could have done that as well. So either way, you're going to get y equals negative x plus 7. A little head nod if you made it that far. Did you make it that far? No? Some people yes, some people no, okay. If not, where did it happen? Did you make it all the way down to here? Yeah, hopefully. If you made it to here and you couldn't make it to here, it's algebra. It's our basic algebra moving things around. So watch that next time. Be careful on that little part. If you know you're making mistakes right there, go a little bit slower next time, try to figure that one out. Hey, are we done? Should I leave it as y equals? You see, we invented that y, right? It's kind of like a dummy variable. It took the place of our function so we could work with it. You have to list it back as whatever function you started with. So if we start with the function f, we better write this thing as f inverse. You see, right now, this is an inverse function of that one, but it doesn't say that yet. That says we just have another function named y. You have to write this back as the inverse function. So instead of y, we write f inverse of x, negative x plus 7. That's our final answer. Yes, no? Yes, you got it? Or no? Some people yes. Everybody? That's good, all right. Do you understand the idea of why we're doing this, why we're finding an inverse? We're trying to find out what function is going to undo this one. That's really important for a lot of your later classes, finding an inverse function there. Now, the last one, we'll do this together. But I want your help on it. The first thing we're going to do, if we have g of x equals 2x plus 3, y'all tell me what's the first thing you'd want to do here?
That's the y.
Y, great, okay, so we're going to have y equals 2x plus 3. Very good. If we have y equals 2x plus 3, the next thing we want to do is what? Okay, switch x. Someone in one of these two rows, tell me what I should have exactly if I switch my x and my y. What's the first thing? Okay, good. So x because y becomes an x. What's now? 2y plus. Yep, that's exactly right. Can you follow how she did that? You follow how she did it. So the x now becomes a y, the y becomes, that's all you're doing. You're not doing any other like mathematics in your head or anything. X's become y's, y's become x's, that's it. Now, can you still solve this thing for y?
Yep.
Sure, let's do that. How do you do it? So x minus 3 equals 2y. You're going to leave it like that?
No.
Ah. Yeah, if we do that, if we divide both sides, that means everything, everywhere. You're going to get x minus 3 over 2 equals y. That's great. That's great. Are we done?
No.
You're very close though. You do have the inverse function, that's right here. You just got to make sure you call that an inverse. So can you tell me if I want to change my y to something that says an inverse, what am I going to change it to?
G inverse.
Wait, now is this appropriate?
No, because the function is not anymore.
So be careful. You're not always putting f inverse, right? Because if we don't have a function f, well, that doesn't make any sense. This would be like, well, go look for your function f. And you're like, what function f? If that's not on the board, what function f, right? So it doesn't stand for that one anymore. We're trying to say this one. If you had a letter g there, we want to say that the inverse is now not f inverse, it's g inverse. Do you follow that? So you got to watch the letter that you're using. And we just rewrite this part, x minus 3 over 2. And we're done. That's our inverse. And in fact, you could check it, right? You could plug in a number. If you plug in a number like, oh, I don't know, 1. You plug in 1 here, you're going to get 5, right? If you plug in 5 here, what should it give you out? If you plug in 1 here, it's going to give you out 5. I can't do that because I'm holding pens. But if you plug in 5 here, what should it give you out? If you plug in, what are you plugging in?
1.
What should this give you out? 1. It should give you out 1. Plug in 1 here. It gives you out
5.
Take the 5, plug it in here. What's it give you out?
1.
It has to work that way. If 1 gives you 5, 5 must give you back 1. You with me on that?
Yep.
5 minus 3 is 2. 2 divided by 2 is 1. Very similar, very, very similar. Go ahead and solve that one. Find me the inverse.
You just ran.
You know what's nice about inverses? They go kind of quick once you get the hang of it. Some of it's just basic algebra put into practice for us, really. Okay, so number one with this h of x. If we have h of x equals 5x plus 2, the first thing we better do is replace that with a y so we can work with it. So y equals 5x plus 2. Did you get that far? Good deal. Next thing we do is we would change our x and our y. We'd switch those things because we're now switching our variables so that we're finding our inverse. That's what the inverse is all about. So we have x equals 5y plus 2. Honestly, raise your hand if you made it that far. Okay, that's the idea of finding an inverse. If you have that down, you have the idea of finding an inverse down. The rest of it's basic algebra, seeing if you can solve for it. So now we would subtract 2, because we're trying to get y by itself here. X minus 2 equals 5y. Of course, we're going to divide by 5. We get x minus 2 over 5 equals y. But we're not going to leave it. We know that this part right here, that is the inverse. That's undoing what that function's doing. That's what's happening here. That's why we're doing this thing. We just got to call that the inverse. So in our case here, we're not going to have f of x or g of x. We're going to have h inverse of x. So h, that little negative 1 is pronounced inverse of x. That's x minus 2 over 5. Did you check it with a point? Did you try it? Try it right now in your head. Pick a point 1 through 5, something easy. Pick any point that you want, plug it in here, and see what you get. Any point that you want. So everyone has a different point right now. Okay. Now, whatever you got out of that, so I pick 1 because 1's easy. I'm going to get 7. I'm going to get 7 out of that function. I'm going to take that 7 and plug it in here. I do 7 minus 2, that's 5. 5 divided by 5 is 1, and that's what I specifically plugged in. Does that make sense? If you picked 4, you would have a little different numbers, but it would give you back out 4 right here. So far, so good? Okay. Now, could you still do it on this one? I want you to notice that when we do switch our variables here, you still need to know how to do it. If we get x equals y minus 2 over 3, can you still solve that for y? You okay on getting that far, by the way? How are you going to solve that for y? So don't forget that you can do that. If you multiply by 3 here, we get 3x equals y minus 2. Of course, just add 2 on both sides. You get 3x plus 2 equals y, and that would be your inverse. Now, I do want to talk about graphically what these things look like. If I have a function, any function, I'm going to make one up right now. Firstly, can you determine that this thing is a function? Function would be vertical line test. Does it pass the vertical line test?
Yep.
Okay. Is it a one-to-one function?
Yeah.
One-to-one would also pass the horizontal line test, saying I don't have any non-unique outputs, says everything's unique. Does it pass the horizontal line test?
Yeah.
That says this is one-to-one. If it's one-to-one, it will have an inverse. Here's what an inverse does. I want you to think carefully, okay? You ready for this? Are you ready for this? You guys awake? It's kind of cool. What we've been doing the whole time to find inverses is simply switching our x with our y. You follow? So if we switch our x with our y everywhere around here, take a random point, for instance. That's the point maybe 1, 3. You follow? That's 1, comma 3. If I switch that, that would give me 3, comma 1. That would be about here. True? If this is, let's see, negative 5, 2, negative 5, 2, it would give me 2, negative 5. So negative 5, 2, it should give me 2, negative 5. It's right down there. What this does, if you imagine this line, that diagonal line, what an inverse does, it flips a function across that diagonal line. That's all it's doing. It's flipping your x and your y, right? So x's become y's and y's become x's. So it's taking this thing and saying, oh, now you are that thing. Well, I tried to draw that as good as I can. It's kind of hard. I'm not an artist. But if this is f, that's f inverse. It says you take your function, and it's flipping it across that diagonal line. That diagonal line, by the way, is the y equals x line. The y equals x line. Just a simple diagonal line. But by flipping your x and your y coordinates, it's taking all of your y's and making them x's, and all of your x's and making them y's. It's flipping those two things. Yeah.
So it just makes it parallel?
No, they're not parallel, they're reflections of each other. They're reflections. It's saying it's a mirror image across that line. Now, I know it doesn't look like a mirror image because it's whatever, but it gains some weight across the line. That's okay. But this should be a mirror image of that function. By switching your x and y, that's exactly what happens. You guys understand graphically what's going on here? So is why the reason why you cannot have a non-one-to-one function, because if you have a non-one-to-one function, when you reflect it, it's not even a function. The horizontal line test would become the vertical line test for inverses. And these have to pass both. Otherwise, you can't find an inverse. Now, one last thing. Here's a way you can check to see if two functions are actually inverses. One kind of important note. Do you remember those compositions we did in the last section, 12.1, where you put one function inside the other function? Remember that? A composition of inverses must give you out x. That's going to be kind of weird, like, wait, x? I thought it was supposed to be like 0 or 1. It should be nothing. Well, what are you plugging into a function? You're plugging in x, right? The composition should give you out x. We'll see that in a second. The composition of a function and its inverse must equal x. So for instance, you familiar with that? The f with that little open circle? F of, if I have this right here, f of f inverse, which means I'm composing f inverse inside of f, that thing has got to be equal to x. Same thing if I do it in reverse. This is the only time in mathematics where you compose two different functions and they equal x. They equal what you're actually plugging back in. Or they equal the same thing in reverse. Do you remember all those times where we did f of g and we did g of f and they were completely different? Do you remember that? This is the only time where you can reverse the operation of that composition and it gives you out the same thing. The only time that happens is if you have an inverse. Let me give you one quick example on how this works. I'll show it to you. And we'll be done. So let's say that I tell you f of x equals 2x minus 5, and f inverse of x equals x plus 5 over 2. And I say, hey, trust me, those things are inverses. Are you going to trust me? Well, yeah, probably because I'm a math teacher and because I'm an honest guy, generally. Generally. Yeah. White lies are just, no, I'm an honest guy. But you would probably trust me, but what would happen if I made a mistake? You've seen me make mistakes in this class, right? This doesn't happen often. But, no, I'm just kidding. But it does happen occasionally. What if I made a mistake? Is there a way you can check my work? Is there a way you can check your work to make sure you actually found the inverse without doing it over again? Because you don't want to just repeat the same mistake over and over, right? Because that won't show you whether you're making a mistake or not. There is a way. Here's the deal. I'll show you this twice. I'll show you each composition. I'll show you they're exactly the same. You only have to show me one of these. So it's your choice whether you want to show me f of f inverse or f inverse of x. Both of these will come out to the same thing. Now, can you tell me, just by looking over here, what do these ultimately have to equal to prove that those are inverses? They got to equal x. Why? Think about it. Look at the board right now. Stop working for a second. What are you plugging in here? It's saying you're plugging in x, right? It's got to go through the function and the inverse. It's going to give you whatever you started with. It's going to give you out that x. That's why you don't get a 1, because you're not plugging in 1. You're taking whatever value I'm saying. That's x. So this thing will ultimately give you out x. Now we're going to go through the function composition really quickly because we covered it last time. If you're talking about f of f inverse, hopefully you remember this. We'd write this first as f of f inverse of x. Do you remember that? Then says, okay, you leave this f, you guys should be pros at this right now. You leave this f alone, but inside you're going to write f inverse. Still so far so good? So if f inverse you now write, well, f inverse. What's the only letter left on the board that represents a function? Are you with me? It says you're going to write f. You're going to go up to, what's f say? 2x. So 2x minus 2x, is this coming back to you? 2x minus 5, that's 2 parentheses. Minus 5. Can you tell me what goes inside that parentheses? Well, that's exactly what we had in that parentheses. Now, what happens? Do you see any simplification you can do? 2's are gone. You get x plus 5 minus 5. 2's are gone. What happens to the 5's? What do you get? So, are these things in fact inverses? If you had gotten anything else besides x, would they have been inverses?
No.
That's it. It's undoing what you plugged in. This said you started by plugging in x, went through both functions and gave you out x. That means the inverse actually undid the function. Now let's see if this works in reverse. I'll bet you $1 billion it does.
I hope it doesn't.
We never have to come.
Need a new car, don't you?
Yeah.
F inverse of f of x. That's the same thing as this. F inverse of f of x. We leave our f inverse, and in the parentheses we put our f. What's our f of x again? So we're going to put our 2x minus 5 inside of our parentheses. What now?
We plug it into the f inverse.
Okay, so we look at f inverse. What's f inverse say?
X plus 5 divided by 2.
X plus 5. So x plus 5 or x plus 5. Are you still okay on this stuff?
Parentheses
I
plus
need to
5.
know how many people feel all right with what we're doing here. If you're not, if you're like, not so. This is our inverses, right? This was our 12.1. You had to be okay at the 12.1 to be able to do this. So we look back at our inverses. We'd say x plus 5 over 2. That's parentheses plus 5 over 2. Can you see that this is actually the f inverse? That really is parentheses plus 5 over 2. What goes inside this parentheses is exactly what I had inside this parentheses. So that's 2x minus 5 over 2. What happens here?
The 5's cancel each other out and the 2's also.
5's are gone. 5's are gone. We're going to get 2x over 2. Of course, if we have 2x over 2, how much is that going to give us?
X.
Did you come up with the same thing both ways?
Yep.
This is the only time in the history of mathematics where you will compose two functions, two different ways and we'll give you the same answer. The only time that happens is if they are inverses. That's it. And that will be x. It will come up with x. Would you raise your hand feel okay with the idea here? So on our day today, on our section, you should know how to do a few things. Firstly, you should know how to find an inverse. If I just give you this, you should be able to find on your own that thing. Nod your head if you can do that. Yes, no? Also, you should know that graphically, all that's happening when I'm flipping my x's and my y's, when I find my inverse, it's taking this function and reflecting it across a diagonal line that's y equals x. That's the second thing. Are you guys okay with that?
Yeah.
Third and final thing, you should be able to check whether two things are functions, whether those two functions are actually inverses by composing them, by taking one of them and putting them inside the other. Now, do you have to show me both? No, I really don't care. Just pick one of them and compose it. Compose your f inverse inside your f of x. If it comes out to x, it's an inverse. If it doesn't come out to x, it's not an inverse. So if you're a little sloppy on this work, go back and look at finding those compositions from the last section. That's going to help you out, because that's all we're doing. We're just composing those things. That's why we went quickly through that. We've already done that. Can you please show me by a show of hands how many people feel pretty good about what we talked about so far? Okay, good. Now, there are some specific functions we are going to talk about. The first one that we're going to cover